Hello, everyone, and welcome back. Today, we are going to learn about fine tuning, a powerful technique that transforms general AI models into a specialized expert for specific task and domain. Let me start with a perfect analogy that matches the visual of this slide. Imagine a robot, a general purpose robot that has basic knowledge about many things. It knows a little bit about medicines, a little about law, a little about cooking, and a little about engineering. It's competent at many tasks, but not an expert at anything specific. Now imagine taking the same robot and sending it to medical school. It learns specialized medical knowledge, studies anatomy, practice diagnosis, understand the treatment, and learns medical terminology. After this specialized training, the robot is no longer just a general helper. It's a medical expert. You can see this in image, the same robot, but now wearing a doctor's coat and stethoscope, representing its specialized medical expertise. This is exactly what fine tuning does to AI models. So let's ask the same question. What is fine tuning? Fine tuning is specialized training for AI models. You take a general AI system like GPT-4 or Claude that has broad knowledge about many topics, and you give it additional focused training on a specific domain, task, or style. The base model already has general intelligence and language understanding from its initial training on billions of web pages. Fine tune builds on this foundation by teaching the model specialized skills or knowledge. So let me explain with a clear definition. Fine tuning is the process of taking pre-trained AI model and training it further on a specific data set to make it expert in a particular domain or task. You might wonder if models like ChatGPT already know about medicine, law, and other fields. Why do we need fine tuning? Great questions. Here is why. So, first thing is depth versus breadth. General models have broad but shallow knowledge. They know something about everything but are not expert in anything. Fine tuning trades breadth for depth, creating a deep expertise in a specific area. Second thing is specified vocabulary and context. So different fields have specialized language. Like medical professionals use terms like myocardial infarction instead of heart attack. Even I cannot pronounce it, and that is the problem. Similar way, legal documents have specific phrasing and structure. Fine tuning teaches the model to communicate like a domain expert. Then third one is a specific task performance. A journal model can write text, but fine-tuned model can write a medical reports in exact format hospital requires. Or journal legal contract that follows a specific template and regulation. The fourth one is accuracy and reliability. For critical applications like medical diagnosis or legal research, you need higher accuracy than a journal model provides. Fine tuning on higher quality domain specific data improves the reliability. And the last one is organization need. So companies often need AI that understand their specific product, process, policies, or brand voice. Fine tuning customize the AI to the organization's unique requirement. Let me walk you through a fine tuning process step by step. Step 1. Start with pre-trained model. You begin with a large general purpose model that already understands language, reasoning, and has broad knowledge. This is your foundation. Training this base model from scratch costs millions of dollars and months of time. Instead of doing that, you get to start with this powerful foundation. Step 2. Gather specialized data. You collect data set specific to your domain or task. For example, for medical AI, thousands of medical journals, case studies, diagnosis records. For legal AI, a legal documents, case law, contracts, regulation, or maybe for customer service AI, your company's past customer interactions, product information, policies. This dataset is much smaller than the original training dataset, maybe thousands or 10,000s of examples instead of billions, but it's highly relevant and high quality. Step 3. Additional training. You train the base model on the specified dataset. The model's existing knowledge is not erased. Instead, it enhanced and specialized. Think of it like a doctor who already knows general medicines, going through a cardiology fellowship to become a heart specialist. Step 4, evaluation and iteration. You, you test the fine-tuned model on your specific task, evaluate its performance, and refine as needed. This might involve a multiple rounds of fine-tuning with adjusted data or parameters. Let me give you a concrete example of how fine-tuning used in different industries. For example, medical diagnosis AI. Imagine a hospital wants an AI assistant to help doctors analyze patient symptoms and suggest possible diagnosis. So, base model GPT-4 has general medical knowledge from reading medical websites, articles during its initial training. Now, with fine-tuning process, the hospital fine-tunes the model on 50,000 anonymized patient cases files with symptoms and confirmed diagnosis, medical textbooks and journals specific to their specialty areas, the hospital diagnosis protocol and treatment guidelines. What is the result? The fine-tuned models now understand the medical terminology at expert level, recognize symptoms patterns specific to disease, follows a hospital diagnosis protocol, provides a suggestion in a format doctor expect, and it has a high accuracy for medical questions than base model. Let's take example 2, legal research AI. A law firm wants an AI to help lawyers to research case law and draft legal documents. So take example of base model of cloud. Cloud has general knowledge about a law firm from its inboarding training. With fine-tuning process, the firm fine-tunes the models on thousands of legal cases and court decisions, legal briefs and motion from their practice areas, specific legal citation format and writing styles, regulatory documents and relevant to their clients. What is the result? Same. The fine-tuned models now understand the complex legal terminology and concepts, can find relevant case specific to related to law, draft document in a proper legal format, cites resource correctly according to legal standards, and understand the specific legal context on the firm's practice. Let's take example of customer service AI. At an e-commerce company wants an AI chatbot to handle the customer inquiries. Base model, a general conversational AI that can chat but doesn't know about the company's product or policies. With fine-tuning process, the company fine-tunes the model on thousands of past customer service conversations, product catalog with detailed specifications, company's policies on returns, shipping, warranties, brand voice guidelines, and approved response. The result is fine-tuned model now knows every product in catalog, understand the company's policy and can apply them correctly, communicate in the company's brand voice, handles common customers issue effectively, and escalate complex issue appropriately. Let's take example of code generation for a specific framework. A software company uses a specific programming framework and wants an AI coding assistance. With base model like a GitHub Copilot can write general code in a many language. With fine-tuning process, the company fine-tunes the model on their code base and internal libraries, documentation for their specific framework, best practice coding standard used by their team, and common pattern and solutions in their project. Result, the fine-tuned models now generate code that follows the company's coding standard, uses their internal libraries and framework correctly, suggests solutions consistent with their architectures, and understand the specific technical context. So this is the power of the fine-tuning. Approaches to fine-tuning depending on your goals. Like first one is task-specific fine-tuning, training the model to excel at a particular task like sentiment analysis, like you want to determine if text is positive or negative. This kind of models is used in a feedback mechanism. Second one is like named entity recognitions, like you want to identify people, places or organization. This kind of model is used in a social media platforms. Then third one is a text classification, so you want to categorize different documents. Now another type of modeling is like domain specific fine tuning, making the model an expert in a field like medical AI, legal AI, financial AI, and scientific research AI. Third type of modeling is like style fine tuning, teaching the model to write in a specific style or voice, like a company's brand voice, a particular author's writing style, formal versus casual communications. And the fourth one is like a behavioral fine tuning, adjusting how the model responds and behaves, like being more concise or more detailed, being more cautious about uncertain information, following the specific ethical guidelines. Let me summarize the key benefits. The first one is improved accuracy. Fine-tuned models perform significantly better on a specialized task than the general model. Second one is customizations. You get an AI that work exactly how you need it for your specific use cases. Third one is efficiency. Fine-tuning is much faster and cheaper than the training a model from the scratch. Fourth one is competitive advantage. A fine-tuned model trained on your proprietary data gives you capability which your competitor don't have. The fifth one is better user experience. Users get more relevant, accurate, and helpful responses. Fine tuning is not without challenges. So, the first challenge with fine tuning is data requirements. You need high quality, relevant data for your fine tuning. Poor training dataset produce a poor result. Second one is cost. While cheaper than training from the scratch, fine tuning still requires computational resources and expertise. Third one, most important, is overfitting risk. If you fine tune too much on a narrow dataset, the model might lose its general capabilities and only work well on very specific inputs. The fourth one is maintenance. As your domain evolves, you may need to update and refine tune your model to keep it current. And the last one is expertise required. Fine tuning requires machine learning expertise to do it effectively, choosing the right parameter, preparing the data correctly, and evaluating the results. So, this is all about fine tuning and how we specialize AI models for specific task and domain. I'll see you in the next video.